Imagine a building that's not just standing there, but literally pulling carbon dioxide out of the air as it grows. I know it sounds like something straight out of sci-fi, but at ETH Zurich, scientists are making this real, and it's actually pretty mind-blowing. So, here's the deal. These researchers teamed up across chemistry, biology, and engineering to create a new kind of living material. It's not just a clever name. This stuff is alive. They've taken photosynthetic bacteria, called cyanobacteria, yep, the same kind that's been around for billions of years, and embedded them inside a special gel. This gel is printable, meaning you can shape it into just about anything using 3D printing. The result? A material that grows, hardens, and, get this, actively removes CO2 from the air. But here's where it gets even cooler. This material doesn't just lock up carbon in its biomass like a tree does. The bacteria actually help turn some of that carbon into solid minerals. Think limestone right inside the material. That means 2 carbon sinks for the price of 1 living cell's solid rock, all packed into your future building walls. And it's surprisingly efficient. Over 400 days, a single gram of this material can capture up to 26 milligrams of CO2. Way more than most other living materials. And even on par with recycled concrete that's chemically treated to do the same job. And unlike your average plant, these cyanobacteria only need sunlight and a little artificial seawater to keep working. Now, the secret to all this is the hydrogel, a water-rich, see-through matrix that lets in light, CO2, and nutrients while keeping the bacteria happy and productive. Plus, with 3D printing, the team can tweak the structure to maximize light and nutrient flow, essentially engineering a perfect little home for these microscopic carbon munchers. But what does this mean for the real world? Well, imagine coating building facades with this living material. Your house or office could become a literal carbon sink, locking away CO2 for decades, maybe even centuries. And this isn't just theory. Artists and architects have already created installations in Venice and Milan using these living blocks. One of them, the Phytoplanktonics project, includes 3-meter-tall structures that can capture as much CO2 as a mature pine tree every year. Of course, we're still at the beginning. There's lots to figure out: scaling up production, keeping the microbes happy over time, making sure everything's safe and sustainable. But seeing living, breathing buildings on the horizon, that's the kind of future I can get excited about. Thanks for watching. And if you love science as much as I do, don't forget to subscribe for more mind-bending breakthroughs.